I am Phil McCaffrey, and this is 8:30 Prep. We have an awesome birthday week because Friday is my birthday. Did you know that?
That's right, I did know that.
Friday is my birthday. So we took yesterday off from Memorial Day. Thank everybody who gave the ultimate sacrifice. Memorial Day is one of my pet peeves because I'm a veteran, and everybody thanks me on Memorial Day, and that's to actually thank people who died. Veterans Day is the day you thank veterans. Anyways, tonight I need to introduce to you one of my excellent friends and great colleague, Dr. Robinsatty. I get to call you Dr. Satty for the first time in public. Say hello, Dr. Satty, and introduce yourself.
Hi, I'm Dr. Robinsatty, the science expert, the test prep science expert.
You sure are.
Thank you for the.
Where'd you go to undergraduate?
I went to undergrad at Brown University in lovely Providence, Rhode Island. I got a bachelor's and master's in biology.
You are a biology nerd, that's for sure, man. I'm afraid of you.
Nerd, but it doesn't end there. I then went on to get my EDD in STEM education from the University of Pittsburgh.
STEM education, what does that stand for? Damien wanted to know.
STEM is science, technology, engineering, and math, and it's one of the big buzzwords of 21st century education. It usually means schools like to spend a lot of money on science and math programs because they make the schools good, but what it actually should mean is an integrated education program that includes projects and activities that have science aspects and math and technology and engineering aspects of the same activity, the same project. We don't see enough of that.
We certainly don't, and I tried to do that when I was a teacher. The biology lab was right next door to the math department, and we tried to do as much math and biology at the same time, so it worked on. So Dr. Satty is going to talk to us tonight about specifically standardized test prep, science, and STEM questions. Now, what is the difference, Robin, between science questions on the ACT and science questions on the SAT?
Science questions on the ACT are actually very similar to the SAT. Both are going to have reading comprehension, heavy on the reading comprehension. The ACT has a lot more graphs, charts, and diagrams than the SAT does. The SAT, when it gives you a science passage, it'll usually be mostly reading with maybe one or two graph questions. The ACT has word and figure questions than reading comprehension questions. And then the ACT will throw in a few questions on content that you need to know ahead of time, whereas the SAT does not.
And the SAT does not have any real science questions, but there is actually some real science knowledge on the ACT. All right, take it away, Dr. Satty.
All right, thanks, Phil. So tonight we're talking about ACT science. This week we'll get to ACT and SAT science. So tonight, science, reading, and content. The ACT science section is like reading because you read. It's mostly reading, actually. You read answer passages, and you usually don't need background knowledge on the content. In fact, it's mostly like reading. Most of what's not like reading is like math. There's numbers and graphs and tables and charts. You often have to determine which numbers are bigger or smaller.
Big on that.
That's often about as advanced as math gets. And you usually don't need background knowledge on the material. It's usually information you can find right in front of you on the page.
I say that's about 90% that you don't need. I say it's about 10% that you actually need knowledge. Would you agree with that, Ruff?
Yeah, I agree. Usually you'll find 2 to 3 questions that require science knowledge, and maybe 1 or 2 more questions where science content can help you answer the question more easily, but you could figure it out alone on your own based on what you see in the passage.
So somewhere,
So
and there's 40 questions. So somewhere around five are real, what you would call real science questions.
yes, five or fewer than that.
Five or fewer.
So
Okay, cool.
there's very little actual science. You can score pretty highly with zero science content. And it's important to remember that the science information that you do need to know is very basic. And we're going to take a look at some examples of that later on. So the science section is unique. The biggest reason it's unique is because you have big, scary science words. Words like Latin names of species, words like the name of a planet or the name of a phenomenon in physics that looks scary, but as long as you can tackle that, you're good. There are also fewer words and more pictures than the reading section, although there are still a lot of words. And sometimes you need to know something about science. As Phil was mentioning, it's only sometimes. In fact, it's only about 10% of the time, maybe 3 to 5 questions on an entire 40 question section. So let's start by focusing on the reading because that's most of what you'll see. 2 rules for succeeding on ACT Science reading. Number 1, don't get intimidated by big scary science words. And number 2, define big scary science words. That's all there is to it. I'm going to show you what that looks like.
I like that.
There's a passage, and I'm going to show you what that looks like. This is a passage from a past ACT, and I'm going to read through it. I'm going to read through it pretty quickly so you're not sitting here all night listening to me read a story, but I'll emphasize the parts that are important for the strategy. When we then look at some questions, I'll show you which parts of the passage are important. You'll see it's not as scary as it looks. So it starts off, the object was a stony asteroid. I know you know the word asteroid. It's not a particularly advanced topic in science, but when you see it at the top of a huge paragraph, when you see it show up a lot, it can get intimidating. The words are big, and it makes the page look scary. So let's break it down. Let's make it a little bit less scary. First, asteroid. We know what asteroid means, but let's say you've forgotten. Let's say you can't remember, is it the rocky thing or the icy thing or the thing that revolves around another thing? It tells you. The passage tells you what that big word means. It's a stony something. So every time we see the word asteroid or stony asteroid, we can cross that out and call it a stone or, even easier, a rock. The object was a rock. As it entered Earth's atmosphere, its high speed created a large pressure difference between the area just in front of the rock and the area just behind the rock. So we just took a slightly intimidating section and made it a whole lot easier. In fact, maybe even a little silly. Maybe you might be reading this during a test, substitute a simple word in, and it might make the passage a little bit entertaining. No, maybe it's just me that finds that entertaining. Phil, do you like this stuff? No.
Oh, I love it, man. I have a degree in engineering. I would never want to have a degree in math or science because I'm not that good at math or science. Engineering is applied math and science, not actual math and science. You guys have I'm not like that persnickety and like putting things in test tubes like you did for your master's degree. It's like really like I'm actually not that I'm like sloppy and messy and just answer questions really well. So I'm good at testing and I'm good at problem solving. And so engineering actually does fit this because I look at the structure. Interesting, you're on the word structural strength. I look at the structure of the ACT and I break it down into how does it always look the same because it's built. And it's built on an equating structure. So no, I have a lot of respect for all of my science and medicine friends. I would never, ever have made it through any of those programs. Way too much reading. Same thing with David going and getting his PhD in literature, like reading all those books. No way, no way I could do it.
And I love the stuff. And whenever I take an SAT, which is surprisingly often for a 30-something adult, I always look forward to the natural science passage and try to skip over the other ones.
Of course you do. I always look forward to the math section.
Mm-hmm. So this happens to be a particularly interesting passage. This paragraph is introduced as there's some big impact that happened. Two scientists suggest what may have caused that impact. All right, let's keep going. The large pressure difference eventually exceeded, and exceeded can be a big word, so I'm just going to cross that out and draw an up arrow. We know that exceeded means is bigger than. Exceeded the structural strength of the asteroid. The rock flattened, decelerated. Even if you don't know the word decelerated, you can probably guess we're talking about the movement of an object, and it sounds like accelerated, but with a D in front of it. So we're going to guess that means slowed down rapidly due to the dramatic increase in surface area and fragmented. Another word, it's not a hard word, but it's a big word, fragmented. We know that fragment could mean piece, so fragmented means something like broke.
Broke. I like broke.
It's short, it's fast, and it makes it look easier. This fragmentation or breaking would have appeared like an explosion. How could you not find this interesting? Calculations show that a comet between 10 meters and 100 meters in diameter would explode at an altitude much higher than 8 kilometers, but a rock of that size would fragment at or near an altitude of 8 kilometers. We're talking about a rock exploding in the air 5 miles above the Earth. It's awesome. I don't know how you could not find this interesting. Recovery of large rock fragments is difficult due to the area's boggy soil. Now, let me tell you, boggy, not the most scientific of terms. We may come back to it later if we have time, but what's important to know is that it doesn't matter what boggy means. All you need to know is that it's an adjective describing soil, and that'll help you answer the question that relates to it.
Now, I do have
small glassy fragments were recovered.
I do have one thing to add now is that numbers are always important. So I would also circle 10 and 100 and 8 kilometers. In my experience, I like to see number words and measurements on this and circle them because I would include this and I would put a big but here. A comet would do this, but a rock would do that. So that's usually a question. So if it's saying a comet is 100 meters in diameter, would explode at 8 kilometers, but the buts always matter. The buts always matter. So there's going to be a question around that.
I was going to save that for later when we talk about the question asks that exact content. But yes, this piece right here will be important later. Phil is absolutely right, and Phil has not read this section quite as many times as I did, so he just pulled that out of his head from his own experience. The more practice you do, the closer you can get to being an expert like Phil is. You'll never be quite that good at it by the time you graduate high school, but the more you practice, the closer you'll get, and the better you'll be able to pick out those sections where a question is most likely to pop up.
I have to contradict you. I have plenty of students who can outscore me all the time. I've got a student right now that in our solutions manual, which you wrote 1/4 of, a student was reading and corrected me. I have a mistake that gets me to the right answer, but I did the problem with the wrong methodology, and he corrected me. And I loved it. I was like, first off, you actually read my PDF. Second off, you went through the answer, and he was like, and he was super polite about it, and he was like, I think you're doing this incorrectly. And I was like, well, cool. And I was super thrilled because that's a lot like scientists. What do scientists say to each other? I think you're wrong, and let me prove you wrong. And so I was like, rock on, bro, read it to me. He read me the question and did the problem, and I was like, well, let's do it your way. And sure enough, we still got the same answer, which was correct, which was, I think, 4. And then I went, oh my God, I wrote this in the solutions manual the incorrect way, which is peer review. I feel like I'm a real scientist now. I've been peer reviewed by
That's what's so
Teen.
exciting about science. That's what makes it so interesting, is that it's always evolving. Is that it's always growing, building upon itself. There's never a final answer. You're never done with it.
No, good. Okay, what's next?
All right. So moving on, let's take a look at a question that might refer to this passage. Here I've reproduced the same section. So in your head, you'll just have to replace the word asteroid with rock. I'm not going to go through and annotate it all over again. You've seen that already. But let's take a look at the question. According to scientists' viewpoint, the altitude, compared to the altitude at which a stony asteroid would have exploded in Earth's atmosphere, a comet of similar size would most likely have exploded at.
Oh my God, you totally,
wow,
I totally nailed it. I totally nailed it.
They're going to think you're cheating. They're going to think we scripted this.
I didn't. You didn't send this to me before. You did send it to me beforehand, but I didn't read it. So, like, typical. I'm a typical student. I looked at it. I looked at how it would look on YouTube, not what it actually said, because I trust what you say. So, go. Sorry, I jumped in. This is the question that I said to highlight.
That spoiled.
I spoiled it.
And
I know the answer.
it's that butt. That butt gave us the question. A comet explodes much higher than 8 kilometers. A rock explodes at or near an altitude of 8 kilometers. So let's say here's your 8-kilometer mark. Here's where your rock would explode, and the comet would be much higher, so your comet would be up here. So a comet of similar size would have exploded at a higher altitude. Done. Phil spoiled the answer.
Sorry.
Thanks for taking my Phil.
Wait a second. Comets are made out of ice, right? So rocks, asteroids are rocks, and comets are ice. So.
Yep. Comets are known to middle school science teachers as dirty snowballs.
Oh, cool.
It's the snowball you get when it hasn't snowed quite enough for snowballs, but you're determined to make one anyway.
Nice. Next. Good job.
All right,
good job, brain.
And even if you didn't know what a comet was, it doesn't matter. It doesn't matter in the context of this.
No, it does not matter.
It's just a thing that is not an asteroid. It's another word. Next question, which is something that shows up a bit, which is what would have happened if. And here it's asking what would have happened if the asteroid had not been flattened by air pressure. So that means we need to find where the asteroid with air pressure, then figure out what happened next, and undo that to answer our question. So we have what would have happened if, and here it's asking.
That was me being amateur.
We have large pressure difference that flattened the asteroid or rock. It then or slowed down quickly. If it did not flatten due to the pressure difference, it would not have decelerated rapidly. That's our answer. It would have decelerated more gradually. It's as simple as that. It has nothing to do with what's going on with the asteroid, deceleration, flattening, pressure differentials. It has nothing to do with that. It's just reading comprehension.
So the reading comprehension that I've noticed so far, Robin, is a lot of mores and less thans, higher than lowers, and just comparing words that... What is it?
The big buts, like you pointed out before.
Yeah, this is higher than, lower than, more than, less than. We get a lot of those.
Yep. It's a lot of comparing different objects, and it doesn't matter what those objects are. if you even know what they are. You don't need to know what an asteroid is. You don't need to know what a comet is for that previous question. You just need to know that they're two different objects and keep track of which one is higher than the other one.
Awesome.
So that's an overview of the reading. Let's talk a little bit about the science content that you're likely to see on the ACT.
Love it.
So you might need to answer 2 to 3 questions based on previous science content you've learned in school, and then another 1 or 2 questions. It can help you answer a question, but you could figure it out with some solid reading comprehension anyway. And then the content is usually very, very easy.
Very easy.
Middle school science level. You're not going to be doing advanced calculus-based physics, which is good because I didn't really pay attention in physics. It's going to be more
neither did I.
along the basics of, mitochondria is the powerhouse of the cell. And I'm sure Phil can explain to you the grammar behind that. That's grammatically incorrect. Mitochondria is plural. Mitochondrion is the singular. So it's actually the mitochondria are the powerhouses of the cell.
Ooh, I learned something.
Which I believe is actually a question on one of the released ACTs. They ask in which organelle is energy produced, or something along those lines.
There's an ATP question that I remember.
Yes. Yep. There's another one that asks that, and you need to know that ATP is energy. Here are a couple other things that you might need to know. I think that the thing that comes up most commonly is a control group.
Control.
Which is the sample or group or trial, the thing that gets either 0 of something or the normal amount of something. If you want to test Tylenol and see how effective it is against headaches, you're going to take 100 people with headaches, give 50 of them Tylenol, and give 50 of them either nothing or a pill that looks like Tylenol but has no Tylenol in it, so we can compare it. If you just take people with a headache and give them Tylenol, and some of them feel better, you don't know if it's because...
I know there's a word there, placebo.
Placebo. Placebo is a great word, and even if you don't see it on the ACT, you might. I've seen it before. You should know about it just to function as an adult in a world with science going over it.
And use it in a sentence. Damien, you are a placebo.
The placebo effect is often why you feel better immediately after taking said Tylenol, even though it really takes a little bit of time to kick in. You can also say that the control group received a placebo pill, so that we know it wasn't the act of the pill that helped the headache. We know it was the medicine in the pill itself.
I love control. Control is true. I see that a lot. You got to know what a control group is.
Yep.
But that's that's middle school level science, isn't it? That's
middle school.
Yeah.
I taught that to my 7th graders.
Right. Yeah, I say this is 7th grade science.
That's definitely middle school. It comes back again. It's the foundation of science. Doing an experiment, having a control group it shows up all the time. But you'll see it first in middle school. Cellular respiration and photosynthesis are nearly mirror images of each other. Cellular respiration is taking glucose, a sugar, adding some things and getting energy out of it, or ATP. Photosynthesis is taking energy from the sun, adding some things, and getting glucose or sugar out of it.
Dude, I love that.
The inputs and outputs are almost exactly reversed from one to the other. It's a basic fact, and it will help you, if not on the ACT, it'll certainly help you in AP Bio. Density comes up quite a bit, and it's important to know that a substance will float on something that is more dense and sink in something that is less dense. Obviously, as long as there's a liquid involved in that story, you can't really float a solid on top of another solid. That's not what floating means. And then friction acts in the opposite direction of an object. Let's say you have a block, because physics is always done with squares, because physicists can't draw. If the block is moving that way, then friction is moving in the opposite direction.
What was your husband's undergraduate degree?
A couple of examples.
What was your husband's undergraduate degree? I hope it wasn't physics.
Say that again?
I said, what was your husband's undergraduate degree, the other Dr. Satty in the family?
Yeah. His undergraduate degree is in mechanical engineering.
That's
Not mechanical engineering. Biomedical engineering. Sorry.
Okay, I knew he had some physics in him.
He's very strongly in applied science. He's very much into applied science, not theoretical science. So he doesn't actually care about the details. It's all about how you can build a bridge or a prosthetic, whatever, that is the best. He's now an emergency medicine physician who does emergency medical service management and organizing big ambulance, helicopter services.
The helicopter thing is super cool.
It is really cool. He is both a flight physician sometimes, but also he helps as medical director of the STAT medevac program here in Pittsburgh. And then when we move to Newark, he'll be helping out with Newark EMS and
awesome.
Possibly getting involved with their state police run medevac helicopter.
And her husband is a humongous dude to get in this tiny little helicopter. So
that's true. He's 6'1" and broad-shouldered. That is not his favorite part of the process, the getting in and out of the helicopter.
All right, what else do you have?
All right, I have a couple of examples for you. First one, in experiments 1 and 2, the students teared the graduated cylinder in each trial so they could more easily determine. So this is an example of a question you don't need to have read the passage for. All you need to know is a little bit of science. And what little science you need to know is so basic. You saw it in 5th grade. And that's you need to know what it means to tear something. To tear something is when you put something...
You rip in half, right? You're tearing
balance. You put something on a balance like a beaker, and you press the button that says tear. And what that does is it resets the balance to 0 grams. You're resetting it so that you can only be measuring what you're adding into the beaker. It's you're essentially subtracting the mass of the beaker before you even get started, so you don't have to worry about the mass of the beaker again.
Okay, true confession. I didn't actually know that. I didn't actually know that.
You did this in 5th grade and in 6th grade and in 7th grade and in 8th grade and every time you did an experiment.
And I actually have answered this passage by going to experiments 1 and 2 and finding mass. So F is the right answer, right? Because we were measuring... Because if you look at experiments 1 and 2, the words mass appear. That's all I ever show students, is that the key word in the answer choice is in the passage, and you circle it and you move on, and who cares what a tear is. I actually did not know that. Now she taught me. I honestly told David I didn't. David was like, how can you not know what to tear is? I'm like, don't teach me. I don't want to know because I can still get the right answer. So I would rather not know.
That's one way to do it. I mentioned in middle school science. So I know what it means to tear something.
I'm making a comment.
Next question is a little bit trickier and definitely requires some science knowledge. But rather than being tricky science, it's tricky because it's confusing. There are lots of pieces to keep straight. Which of the following best explains why equal masses of O2 and CO2 at the same temperature and in the same size vessel had different pressures? I did not choose to underline same temperature and in the same size vessel because they're assumptions. Once they're given to you, you should just ignore them, and because you don't need to consider it anymore. It means that your temperature, your T is constant. It means that your volume is constant. We want to know why equal masses have different pressures. For this, we need to know a little bit about O2 and CO2. Not a lot about them. O2. Let's say that's O2. It's made up of 2 oxygen molecules, 2 oxygen atoms, to make up 1 molecule. CO2 is made up of 2 oxygen atoms and a carbon atom. That makes it a little bigger. Not a lot bigger, but a little bit bigger. So an equal mass of both of them, since O2 is a little smaller, you'll have more O2 molecules for the same mass than the number of CO2 molecules that you'll have. More molecules means they bounce around more, they bump into each other more than the CO2 molecules will, which means you'll have higher pressure. Pressure is just the bouncing around of molecules. So more molecules per gram means higher pressure. So the pressure exerted by O2 was greater because there are more O2 molecules.
You should write a book on this.
Pretty big chemistry.
Where's my book?
It sounds pretty interesting. Perhaps. Problem is, it's such basic science, the book's been written, and the book was written 100 years ago.
No, I meant you should write a book on ACT, how to take the ACT science section. I forgot.
I get it. I got it. It's a joke because I wrote a book on ACT science.
And I forgot to show it. I'll bring it tomorrow night. I promise. You got to.
All right. I have two. I also forgot to bring it with me. Yeah, I should write a book. I wrote a book. It's actually really good. It's also really short, so you can get through it pretty quickly. So those are a couple of examples of content-only ACT questions. And I'm sure we're running out of time, but before we wrap up, I have a couple of questions where content and reading are both needed to help you answer a question. So for this particular question, I'm going to skip through. I'm not going to read it all. I'm just going to show you the part that you need to know. If you need to pause the YouTube video so you can go back and read it on your own, you're welcome to do so. The question asks.
Plus, we'll have in the.
Was controlled in the design.
We'll have in the link below the PDF, right? I froze you. I'm sorry. Go ahead.
Which of the following variables is controlled in the design of study 2? In this particular case, controlled is not the same as a controlled group that we talked about earlier. In this context, and you'll see this pretty often, controlled means the same as kept constant. You may know the word constant from your own middle school science class, or kept the same. So which of the following variables was kept the same? You need to know what controlled means, but you can also kind of figure it out based on your understanding of the word control. So content helps you here, but you also need that reading. And you would find in the passage that 2 seed dishes were placed in each site, one containing 20 species A seeds and one containing 20 species B seeds. Where they say 2 seed dishes were placed in each site, each seed dish had the same number of seeds. That's the thing that is kept constant or controlled or the same. And so it's the number of seeds placed in each site. And then here's a great example of where content helps. Content turns a medium hard question into an easy question, but it's not necessary. This is the scientist 1 argument from the same passage as before, where scientist 2 was arguing that it was a rock. Scientist 1 is arguing that it is a snowball, a comet, a body made of ices. So comet, snowball.
Wait, it's made out of frozen
question,
methane?
Scientist 1 viewpoint indicates that the material.
I'm sorry, I interrupted you.
What did you say about methane?
I said, is a comet frozen methane? Is a comet frozen methane? That's awesome.
It could be. It could be. Space is so
Which means it's a big frozen fart.
All sorts of crazy things freeze.
Which right? Cows fart methane, don't they?
Yeah.
That's awesome. Sorry.
Yep, cows fart and burp methane. It's actually a huge contributor to the greenhouse effect and global climate change.
Damn McDonald's.
Cow burps and farts. So the materials, when they're heated, they change too. So all you need to see in the reading passage here is that most of this commentary, seriously, you don't need commentary. That's just unnecessary. They're just messing with you. Most of this comment material is volatile or easily vaporized. If you don't know what vaporized means, you look at the word, you see vapor, and you think, oh, it probably turned into a gas. And you get your answer.
Because it's methane.
If you're familiar with your science content, you know that vaporization is when a material turns into a gas, which gives you your answer a little bit easier, a little bit more easily. So you don't need to know what vaporization is here, but it helps make the question a little more easy. It helps you be a little bit more confident in your answer. Now, I have a couple more examples, but I also know it's getting late.
It is getting
Phil, do
late.
you want to see more examples, or do you want to wrap it up?
I think we're past 9 o'clock. We try to keep it to about a half an hour because teenagers are our brains. But we got Peyton. Peyton's on, so which is always awesome. So Peyton, you didn't get anybody to argue with you today over the robots. So last week during essay week, they got into an argument on who built the best robots, and I learned that robots are made out of Legos. So I'm learning so much with all my guests. So actually, what's going on tomorrow? You're on all week, so maybe we can get some questions.
All week, although it's a short week.
It's a short week. But you're doing great. So tomorrow is what? Charts and graphs on the ACT?
Yep. Tomorrow is tables, graphs, and figures on the ACT. Guess what? It's really easy, and you learned everything you need to know in middle school. So it'll be pretty easy. But fortunately, it's science, so it'll be really interesting too.
And what's Thursday?
Thursday is going to be SAT-specific science. So it's going to be the reading and brief graph or table questions that you'll see on the SAT Natural Science section.
Excellent. And the best way to reach you is robinsatty@gmail.com. I will put that in the description because if you want an excellent SAT or ACT tutor, my good friend Robin Satty is experienced in it, particularly if you want to look at how to read a chart and a graph, because she's better at reading charts and graphs than me. And she has written my section of my book, soon to be published. Will is almost done with it. We've only been working on it for 5 years, so Robin wants to show it off. I promise you it will be available on Amazon, and I will hand deliver a copy through social distancing before you move to New Jersey. That's my promise to you. So when are you moving? When are you moving?
Gosh, that depends on when we close on the house, but hopefully mid-July.
Mid-July. All right, I got 6 or 7 weeks. All right, I'm Phil McCaffrey. This is 8:30 Prep. Say goodnight to Damien.
Good night.
Say goodnight to Dr. Satty. You will see her tomorrow for ACT charts and graphs. Thursday is SAT specific STEM questions, which she actually is a pretty big nerd about, aren't you? You actually like the nerdy sections. She's like, oh, look, a nerdy section. All right. Thank you very much for watching. We'll see you tomorrow night, which is May the 27th on Wednesday. I hate getting messed up on my days. I'm like COVID unaware of days, you know? It was really strange. So thanks, Robin. We'll see you tomorrow. Stay on.